fourth graders. Today we're going to work in lesson 3.3, working on number lines and equivalence. Today you will just need your math journal. You do not need your whiteboard today for the lesson. So we're going to go ahead and open up our math journals to page 73. Would you please open your math journal to page 73? Remember, I try to enlarge mine so it's a little bit easier for you to see. So you might not see the entire page on mine, but it matches your math journal exactly. Up at the top, it says fractions on numbered lines. Fill in the missing fractions on the number line. So the first thing I'm going to do is go ahead and figure out how many equal spaces are there on this number line. This is how I'd count. 1, 2, 3, 4. I also see that it shows there are fourths. So what I'm going to go ahead and do is to fill in right now fourths on each of those missing lines. So in our first one, we have 1/4. So let's go ahead. The next line would be 2/4. The last line would be 3/4. Another way to say a whole number 1 would be 4/4. Let's look at number 2. Let's count how many equal spaces there are. 1, 2, 3. So in number 2, each of these lines will have thirds as its denominator. On the first space would be 1/3 of the line, and the next one would be 2/3. Let's look at number line number 3. I'm going to go ahead again and count the spaces. 1, 2, 3, 4, 5, and 6. So this line is divided into 6. So I'm going to go ahead on each of those lines and fill in 6 as my denominator. Now I'm going to go ahead and fill in the numerator, the number above the fraction line. So this would be 1/6 of the line, 2 out of 6, 3/6, 4/6, and 5/6. If I said 6/6, that would be the whole number line, 6 out of 6 equal pieces. Looking at number 4. Again, I'm going to count an equal number of spaces. 1, 2, 3, 4, 5, 6, 7, and 8. So my fractions are all going to have 8 as the denominator. That tells me how many equal spaces are on this number line. So go ahead and now fill in the numerator, the top number. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and the whole number 1 would be the same as 8/8. When the top number and the bottom number are the same, it equals 1 whole. Now, number 5 is a little bit different. I'm going to see that this number line is actually goes to the number 3. So remember how I said when the top number and the bottom number are equal, they are the same, that equals 1 whole. So this part of the fraction line would equal 1 whole. So now what I'm going to do is count how many equal spaces there are between 0 and 1. 1, 2. So notice the denominators 2 on all of these. So go ahead and fill those in, because this number line is divided into 2 equal segments between 0 and 1, 1 and 2, and 2 and 3. So this would be 1/2, 2/2, 3/2, 4/2, 5 halves, and the whole number 3. Now, we don't usually say 4 halves. What we would say is half, 1, 1.5, 2, 2.5, and 3. What we would call these would be equivalent fractions. 4 halves is the same as 2. 3 halves is the same as 1.5. 2 halves is the same thing as 1 whole. Now we're going to look at number line number 6. What I notice is that it divides to the whole number 2. So I'm going to find where the whole number 1 is, where the top number and the bottom number are equal. Why don't you write the number 1 underneath 5/5? What that tells me is between 0 and 1, there are 1, 2, 3, 4, 5 equal parts. So this number line throughout the whole number line is divided into fifths. Go ahead and fill that in on your number line. So our first one would be 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5 is done, 9/5, and this one would be 10/5. Now we don't usually, we use what we call a mixed number. So once I get to 1, put this underneath, will you? This would be the same thing as saying 1 1/5, 1 2/5, 1 3/5, 1 4/5, and then we would say the whole number 2. So what you need to know is to count how many equal spaces there are on a number line and to be able to identify that as the denominator. We're going to move on to one other page, and that is page 75. And at the top it says equivalent fractions. The other day we used our fraction pieces to name equivalent fractions of a whole circle. Today I'm going to teach you a shortcut because we might not always want to pull out all of those fraction pieces. It says use the equivalent fractions poster on journal page 74 to help you solve the problems below. And if I were going to be in class with you, I would have you divide that into halves, into fifths, and tenths. But I'm going to teach you a shortcut. So if you look at number 1, I'm just going to write it a little bit larger. So what I'm going to do is I'm going to say to myself, let's look at the numerator. What did they multiply 1 by to give you 2? Well, 1 times 2 equals 2. So if I multiply that same number on the bottom, does it equal 10? 5 times 2 is 10. Yes, 1/5 and 2/10 are the same. So I'm going to go ahead and circle that. I'm going to write out the second one. 3/6 equals 4/12. Are those equivalent? Let's start with the denominator this time because it makes it a little bit easier. 6 times what would give me 12? Well, 6 times 2 would give me 12. So if I multiply the bottom by 2, I'm going to multiply the top by 2. Because it would be like if I gave one of you 2 of something, but I didn't give the other group 2 of something. They would say, that's not fair, that's not equal. The fractions say the same thing. So if I multiply the bottom by 2, I'm going to say, is 3 times 2? 3 times 2 is not 4, it's 6. So this is not equivalent. Let's try the next one. It says 4/10 equals 2/5. Well, I can move the opposite direction. I can say it this way too. 5 times 2 is 10. So if I multiply the bottom by 2, I have to multiply the top by 2. Is 2 times 2 4? It is. So those two are equivalent. Let's take the next one. Halves are usually pretty easy fractions to figure out. It's asking, is 1/2 equal to 5 tenths. Well, I'm going to multiply 1 times 5 to give me 5. So if I take the top times 5, I have to take the bottom times 5. Is 2 times 5 10? Yes, it is. So these two are equivalent. Go ahead and circle it. The next one, 4/5. Does that equal 9/10? In this case, it makes sense to start on the bottom, the denominator. I know that 5 times 2 is 10, so if I multiply the bottom by 2, I would multiply the top by 2. Let's see if 4 times 2 is, it's not 9, is it? 4 times 2 is 8. So this is not equivalent. It would have to have an 8 on the top. They are not equivalent. Let's try one more in number 1. 1/5 equals 1/3. I see something already. They multiply 1 times 1 to get 1. So then I would multiply the bottom by 1. Doesn't make sense if I ate 1/5 of the pizza and my friend ate 1/3 of her pizza. We ate the same amount. No, those are not equivalent. So we had 3 that were equivalent or equal and 3 that were not. Let's move on to the next one. Number 2 says insert an equal, or this symbol means not equal. Make that a little bit neater for you. This means not equal. To make the number sentence true. So again, I'm just writing this a little bit larger. So what I'm going to do is use the same thinking that I did on the first problem, except for I'm going to start this direction. 5 times 2 is 10, so I have to take the top number times 2, because whatever I do to the bottom, I do to the top. Is 4 times 2 8? Yes. So they are equal. Would you go ahead and put in an equal sign? Let's move on to 2B. 2B. We have 2/3 and 8/12. And we're going to find out if they are equivalent. So I'm going to start at the top. I know that 2 times 4 equals 8. So if I take the top number times 4, in order for it to be equal, I'd have to take the bottom number, the denominator, times 4. Is 3 times 4 12? Yes. They are equal. Go ahead and put an equal sign. Oh, I look at 2C, reminds me of one that I did not too long ago. How can my fractions be equal if the top number is the same but the bottom number is different? So let's take a look at it. I know that 1 times 1 would give me 1. So if I multiply the top by 1, I would multiply the bottom by 1. Is 6 times 1 10? No. So these are not equal. So I draw a diagonal line through an equal sign. And lastly, for number 2, 5/10. Does that equal 3/6? Well, what I'm going to do is say, I noticed something. Watch this for a minute. What's half of 10? 5. So this would be the same as saying half. Let's look at this. What's half of 6? 3. Guess what? You should be able to identify easily what half of a number is. So both of these, 5/10 is half, 3/6 is half. Guess what? They are equal. And lastly, we're going to do number 3. You can put one extra number 4. We won't get to that one today. Here we're finding the missing number. So again, I want you to actually write this in your math journal. So on the bottom, 3 times 4 gives me 12. So if I multiply the bottom by 4, I have to multiply the top by 4. And 1 times 4 is 4. Here, I'm going to multiply by 6. So I have to multiply by 6 to get 12 on the bottom. What number times 6 would give me 12? 2. Here they multiplied 5 times 2 to give you 10. So what can you multiply by 2 to give you 6? 3. Here they multiplied by 3 to give you 6. So if you multiply the top times 3, so whatever you do to the bottom, you have to do to the top. 1 times 3 is 3. Here, they multiplied or divided by 2, depending on which way you're going. 1 times 2 is 2. So if we multiply the bottom by 2, what number times 2 gives me 6? That is 3. And the last one. Here, they took 4. We can move either direction. It doesn't matter. 2 times 4 is 8. So 6 times 2 would be 12. Make sure you fill that in as you're watching the video.